Steven Weinberg is an American theoretical physicist and Nobel laureate in physics for his contributions with Abdus, Salam and Sheldon Glashow to the unification of the weak force and electromagnetic interaction between elementary particles. He holds the Josey Regental Chair in Science at the University of Texas at Austin, where he is a member of the Physics and Astronomy Departments. His research on elementary particles and cosmology has been honored with numerous prizes and awards, including in 1979 the Nobel Prize in Physics and in 1991 the National Medal of Science. In 2004 he received the Benjamin Franklin Medal of the American Philosophical Society, with a citation that said he is considered by many to be the preeminent theoretical physicist alive in the world today. He has been elected to the U.S. National Academy of Sciences and Britain's Royal Society, as well as to the American Philosophical Society and the American Academy of Arts and Sciences. Weinberg's articles on various subjects occasionally appear in the New York Review of Books and other periodicals. He has served as consultant at the U.S. Arms Control and Disarmament Agency, president of the Philosophical Society of Texas, a member of the board of editors of Daedalus magazine, the Council of Scholars of the Library of Congress, the Jason Group of Defense Consultants, and many other boards and committees. Education and early life. Steven Weinberg was born in 1933 in New York City. His parents were Jewish immigrants. He graduated from Bronx High School of Science in 1950. He was in the same graduating class as Sheldon Glashow, whose own research, independent of Weinberg's, would result in him sharing the same 1979 Nobel in Physics. Weinberg received his bachelor's degree from Cornell University in 1954, living at the Cornell branch of the Telluride Association. He left Cornell and went to the Niels Bohr Institute in Copenhagen, where he started his graduate studies and research. After 1 year, Weinberg returned to Princeton University, where he earned his Ph.D. degree in physics in 1957, for research supervised by Sam Traiman. Career and research. After completing his Ph.D., Weinberg worked as a postdoctoral researcher at Columbia University and University of California, Berkeley, and then he was promoted to faculty at Berkeley. He did research in a variety of topics of particle physics, such as the high-energy behavior of quantum field theory, symmetry breaking, pion scattering, infrared photons and quantum gravity. It was also during this time that he developed the approach to quantum field theory that is described in the first chapters of his book The Quantum Theory of Fields, and started to write his textbook Gravitation and Cosmology. Both textbooks, perhaps especially the second, are among the most influential texts in the scientific community in their subjects. In 1966, Weinberg left Berkeley and accepted a lecturer position at Harvard. In 1967 he was a visiting professor at MIT. It was in that year at MIT that Weinberg proposed his model of unification of electromagnetism and of nuclear weak forces, with the masses of the force carriers of the weak part of the interaction being explained by spontaneous symmetry breaking. One of its fundamental aspects was the prediction of the existence of the Higgs boson. Weinberg's model, now known as the Electroweak Unification theory, had the same symmetry structure as that proposed by Glashow in 1961. Hence both models included the then unknown weak interaction mechanism between leptons, known as neutral current and mediated by the Z boson. The 1973 experimental discovery of weak neutral currents was one verification of the electroweak unification. The paper by Weinberg in which he presented this theory was one of the most cited theoretical works ever in high-energy physics as of 2009. After his 1967 seminal work on the unification of weak and electromagnetic interactions, Steven Weinberg continued his work in many aspects of particle physics, quantum field theory, gravity, supersymmetry, superstrings and cosmology, as well as a theory called technicolor. In the years after 1967, the full standard model of elementary particle theory was developed through the work of many contributors. In it, the weak and electromagnetic interactions already unified by the work of Weinberg, Abdus, Salam and Sheldon Glashow, are made consistent with a theory of the strong interactions between quarks, in one overarching theory. In 1973, Weinberg proposed a modification of the standard model which did not contain that model's fundamental Higgs boson. Weinberg became Huygens Professor of Physics at Harvard University in 1973. In 1979, he pioneered a modern view on the renormalization aspect of quantum field theory that considers all quantum field theories as effective field theories and changed the viewpoint of previous work that a sensible quantum field theory must be renormalizable. This approach allowed the development of effective theory of quantum gravity, low-energy QCD, heavy quark effective field theory and other developments, and it is a topic of considerable interest in current research. In 1979, some 6 years after the experimental discovery of the neutral currents, i.e., the discovery of the inferred existence of the Z boson, but following the 1978 experimental discovery of the theory's predicted amount of parity violation due to Z bosons mixing with electromagnetic interactions, Weinberg was awarded the Nobel Prize in Physics, together with Sheldon Glashow and Abdus Salam, who had independently proposed a theory of electroweak unification based on spontaneous symmetry breaking. In 1982, Weinberg moved to the University of Texas at Austin as the Jack S. Josey Welch Foundation Regents Chair in Science and founded the theory group of the Physics Department. There is current interest in Weinberg's 1976 proposal of the existence of new strong interactions, a proposal dubbed technicolor by Leonard Susskind because of its chance of being observed in the LHC as an explanation of the hierarchy problem. Steven Weinberg is frequently among the top scientists with highest research effect indices, such as the H-index and the creativity index. Other contributions besides his scientific research, Steven Weinberg has been a prominent public spokesman for science, testifying before Congress in support of the superconducting supercollider, writing articles for the New York Review of Books, and giving various lectures on the larger meaning of science. His books on science written for the public combine a typical scientific popularization with what is traditionally considered history and philosophy of science and atheism. Weinberg was a major participant in what is known as the Science Wars, standing with Paul R. Gross, Norman Levitt, Alan Sokal, Lewis Wolpert, and Richard Dawkins, on the side arguing for the hard realism of science and scientific knowledge and against the constructionism proposed by such social scientists as Stanley Aronowitz, Barry Barnes, David Bloor, David Edge, Harry Collins, Steve Fuller, and Bruno Latour. Personal life. Weinberg married Louise Weinberg in 1954 and has one daughter, Elizabeth. Politics. Weinberg is also known for his support of Israel. He wrote an essay titled Zionism and Its Cultural Adversaries, to explain his views on the issue. Weinberg has cancelled trips to universities in the United Kingdom because of British boycotts directed towards Israel. He has explained, given the history of the attacks on Israel and the oppressiveness and aggressiveness of other countries in the Middle East and elsewhere, boycotting Israel indicated a moral blindness for which it is hard to find any explanation other than antisemitism. Religion. Weinberg is an atheist. His views on religion were expressed in a speech from 1999 in Washington, D.C. Religion is an insult to human dignity. With or without it you would have good people doing good things and evil people doing evil things. But for good people to do evil things, that takes religion. He modified his comment in a later article derived from these talks. Frederick Douglass told in his narrative how his condition as a slave became worse when his master underwent a religious conversion that allowed him to justify slavery as the punishment of the children of Ham. Mark Twain described his mother as a genuinely good person, whose soft heart pitied even Satan, but who had no doubt about the legitimacy of slavery, because in years of living in antebellum Missouri she had never heard any sermon opposing slavery, but only countless sermons preaching that slavery was God's will. With or without religion, good people can behave well and bad people can do evil, but for good people to do evil, that takes religion. He has also said, the more the universe seems comprehensible, the more it seems pointless. He attended and was a speaker at the Beyond Belief Symposium in November 2006. Honors and awards. The honors and awards that Professor Weinberg received include Honorary Doctor of Science degrees from a dozen institutions: University of Chicago, Knox College, University of Rochester, Yale University, City University of New York, Dartmouth College, Weizmann Institute, Clark University, Washington College, Columbia University, Bates College, American Academy of Arts and Sciences, elected 1968. National Academy of Sciences, elected 1972. J. Robert Oppenheimer Memorial Prize, 1973. Danny Heinemann Prize for Mathematical Physics, 1977. Steele Foundation Science Writing Award, 1977, for writing the first 3 minutes. Elliott Cresson Medal, 1979. Nobel Prize in Physics, 1979. Elected a foreign member of the Royal Society in 1981. Elected to American Philosophical Society and Philosophical Society of Texas. James Madison Medal of Princeton University, 1991. National Medal of Science, 1991. Lewis Thomas Prize for Writing About Science, 1999. 2002 Humanist of the Year, American Humanist Association. Benjamin Franklin Medal for Distinguished Achievement in the Sciences, American Philosophical Society, 2004. James Joyce Award, University College Dublin, 2009. Selected publications. A list of Weinberg's publications can be found on the Arxiv and Scopus. Bibliography. Books authored, co-authored: Gravitation and Cosmology, Principles and Applications of the General Theory of Relativity, The First 3 Minutes, A Modern View of the Origin of the Universe, The Discovery of Subatomic Particles, Elementary Particles and the Laws of Physics, the 1986 Dirac Memorial Lectures, Dreams of a Final Theory, The Search for the Fundamental Laws of Nature, ISBN 0-09-922391-0, The Quantum Theory of Fields, Facing Up, Science and Its Cultural Adversaries, Glory and Terror, The Coming Nuclear Danger, Cosmology, Lake Views, This World and the Universe, Belknap Press of Harvard University Press, ISBN 0-674-03515-1. Lectures on Quantum Mechanics. To Explain the World. The Discovery of Modern Science, HarperCollins Publishers, ISBN 978-0062346650. Scholarly articles. Weinberg, S. A Model of Leptons. Phys. Rev. Let. 19. 1264-1266. Bibcode 1967 PHRVL 19.1264W. DOI 10.1103, Physrevlet 19.1264. Weinberg, and G. Feinberg, Law of Conservation of Muons, Columbia University, University of California, Berkeley, United States Department of Energy. Pais, A. Weinberg, S. Quigg, C. Reardon, M. Panofsky, WKH, and V. Trimble. 100 Years of Elementary Particles, Stanford Linear Accelerator Center, United States Department of Energy, Beamline, Volume 27, Issue 1, Spring 1997. Weinberg, S. Pions in Large N Quantum Chromodynamics. Phys. Rev. Let. 105, 261,601, Arxiv 1009.1537, Bibcode 2010 PHRVL 105Z1601W, DOI 10.1103, Phys.Revlet 105.261601, Weinberg, S. Collapse of the state vector. Phys. Rev. 85, 062116, Arxiv 1109.6462, Bibcode 2012 PHRVA 85F2116W, DOI 10.1103, Phys.Reva 85.062116. Popular articles. A Designer Universe. A refutation of attacks on the theories of evolution and cosmology is based on a talk given in April 1999 at the Conference on Cosmic Design of the American Association for the Advancement of Science in Washington, D.C. This and other works express Weinberg's strongly held position that scientists should be less passive in defending science against anti-science religiosity. Beautiful Theories. An article reprinted from Dreams of a Final Theory by Steven Weinberg in 1992 which focuses on the nature of beauty in physical theories. The Crisis of Big Science. May 10, 2012, New York Review of Books. Weinberg places the cancellation of the superconducting supercollider in the context of a bigger national and global socio-economic crisis, including a general crisis in funding for science research and for the provision of adequate education, healthcare, transportation and communication infrastructure, and criminal justice and law enforcement.